Okay, y'all, we are going to talk about the next sense we have, which is audition or hearing. But anytime we're discussing our ability to hear, we're using this term, audition. We're also going to look at the makeup of the ear, just like we did the eye. So the eye and the ear are similar in terms of sensation and perception and transduction, and we're going to talk about why that is. So keep that in mind as we're going through this. This video, the TED Ed Science of Hearing, is going to be posted under this video on Canvas, but also let's say for whatever reason, this video doesn't work for you. Great news, Google TED Ed, the Science of Hearing, and it'll come right up. But I encourage you to watch this. If you cannot find it on Canvas or the link does not work, just search TED Ed, the Science of Hearing. It's super awesome. Now, this is a picture of our ear, and we divide our ear into three parts. We have the outer ear, which is just what's visible. And then we have the inner ear, or excuse me, the middle ear, which starts at the eardrum, comes until here. And in the inner ear, we have the eardrum, hammer, anvil, stirrup. These are three tiny little bones that are all connected based on the vibrations that hit the eardrum. And then we have the inner ear, which are the semicircular canals, cochlea, and inner ear. And our vestibular sense comes from our inner ear, which is based on our semicircular canals, but our cochlea is where transduction occurs. Okay, this is a D, sorry. Okay, now, excuse me, let's continue. So when we're looking at our basilar membrane, it is inside of the cochlea, and it's lined with these tiny little hair cells inside of the cochlea that are connected to something called the organ of Corti. And the vibrations that come from sound waves are turned into neural messages or transduced into neural messages, and then they're sent via the auditory nerve to the auditory cortex in our temporal lobe. Basilar membrane is super important. Now, we have two types of hearing theories. We have place theory or we have frequency theory. When we hear pitch, it's based on where the sound lands on the basilar membrane. So when the sound hits here, 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 that creates a certain pitch compared to if it hit like here, here, or here, that would be a different pitch. That's place theory, where the sound hit the membrane. And it explains why we have like high pitches and where the sound came from. But frequency theory is when we hear pitch bases based on how fast or frequent the hairs on the basilar membrane vibrate. So this explains low pitches and how fast the sound is. So if it's like, this is the frequency, that's going to be reflected on how it's translated or transduced on the auditory nerve compared to if it's like slower, that will also translate, when it's transduced onto the auditory nerve. Again, here is a great video that is going to be posted on Canvas under this video, which shows the science of hearing and explains the process of the sound waves seen here. Oops. The sound waves seen here entering the ear vibrating on the eardrum, which moves the hammer, anvil, and stirrup, and then translates into the inner ear, and voila, it continues to our temporal lobe or auditory cortex. This right here is our throat. Now, when we look at sensory neural versus conductive hearing loss is when something has gone wrong in the outer and middle ear. Whereas sensory neural is something has gone wrong in the inner ear, like something's wrong with our cochlea, for example. And when that happens, we have to treat those two things differently. If you have sensory neural hearing loss, you might get something called a cochlear implant, which is a device that will be attached to your brain right over your cochlea. And it's designed for people to have moderate to severe sensory neural hearing loss due to damage or infection in their inner ear, which means they have difficulty interpreting speech, even with a hearing aid, because a hearing aid helps this process, the conductive hearing loss, but a cochlear implant helps the sensory neural. So a cochlear implant may be right for those who are struggling to understand speech, even with a hearing aid that's properly fitted. Or those who may not have been born with fully functioning cochleas. For example, if you have a cochlear implant at birth, like you need one, and your parents realize, oh, my child's not hearing me, they can put a cochlear implant on pretty young, and then you're able to start improving your hearing and ability to understand spoken language in a way that if you grow up without the sense of hearing, it can become more and more difficult because you didn't develop that sense. However, there is controversy surrounding the cochlear implant. People in the deaf community feel like we don't need to hear the way other people do. We can use ASL or American Sign Language, and there's nothing wrong with that. And by trying to make a deaf person a hearing person, you're disrespecting the community and like inherently saying there's like something wrong with them, something to be fixed, when that's not necessarily true. Also, the sounds of the cochlear implant, they do sound different than like how I'm talking to you. If you are a hearing typical person, it can come off as kind of like mechanical, robotic, or cartoonish. And it can sound almost to the people with a cochlear implant like someone's talking with marbles in their mouth. So it has its pros and cons. Obviously, the pros will, help you understand language better, communicate with people who hear typically easier and don't speak American Sign Language, but it's like all the good things in life has its pros and cons. Now, our vestibular sense comes from our inner ear. Our vestibular sense is our balance and equilibrium. So like our body and head position, it comes from the fluid-filled sacs in the ear, and is responsible for motion sickness. So if you are on a boat or a roller coaster and you get off and you're kind of like a little dizzy or off your balance, it's because your vestibular sense in the liquid in your semicircular canals has been disturbed. Now, I want you to write these down: ear canal, ossicle bones, cochlea, basilar membrane, eardrum, auditory nerve, temporal lobe, and sorry. Your ossicle bones are the hammer, anvil, stirrup. and I want you to explain audition, which this is like the order that audition, actually, I don't know why I said that, sorry, but these are all the parts of the ear that audition occurs in, and I want you to be able to talk about each one's role, and I even encourage you to put them in order so that you can visualize and see how sound waves enter the ear and eventually reach the auditory cortex in our temporal lobe. If you have any questions, please email me. I really encourage you to watch those 2 videos I mentioned, and if you need any help, I'm here for you. Thanks for tuning in.